Hey everyone, and welcome back to the channel. Or if this is your first time here, a massive hello. Today, we're diving deep into the fascinating and incredibly powerful world of Kubernetes. Now, you might have heard this buzzword floating around, or maybe you're already wrestling with managing containers at scale. Either way, you're in the right place. Let's face it. Containers like Docker have revolutionized how we build and deploy applications. But what happens when you're not dealing with just one or two containers? What about dozens, hundreds, or even thousands? How do you manage them all? How do you make sure they're running smoothly, scaling automatically, and healing themselves when things go wrong? This, my friends, is where the container chaos begins. That's where our superhero enters the scene, Kubernetes. Often abbreviated as K8s, Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Think of it as the conductor of an orchestra, making sure every instrument, in our case, every container, plays in harmony. To understand how Kubernetes works its magic, we need to grasp some fundamental concepts. These are the building blocks of any Kubernetes deployment. First step, we have the pod. This is the smallest deployable unit in Kubernetes. It's not a container itself, but rather a group of one or more containers that are always scheduled together on the same host. They share resources like storage and network, making it easy for tightly coupled applications to work together. Think of a pod like a single apartment unit in a building. It can house one or more roommates, containers, who share common utilities. Next, we have nodes. These are the worker machines where your pods actually run. A node can be a physical machine or a virtual machine. The control plane manages these nodes, deciding where to place pods based on resource availability and other constraints. Nodes are like the individual buildings in our apartment complex. Now, put it all together and you get a cluster. A Kubernetes cluster is a set of node machines that run containerized applications. It's orchestrated by the control plane, which is the brain of the Kubernetes system. The control plane is responsible for making global decisions about the cluster, like scheduling applications and managing the desired state. Key components include Kube API Server, which is the front end for the Kubernetes control plane, exposing the Kubernetes API. etcd, a highly available key value store used as Kubernetes backing store for all cluster data. Kube Scheduler, which decides which node new pods should run on. Kube Controller Manager, which runs controller processes that manage the state of the cluster, like replica sets and deployments. Kubelet, which is an agent that runs on each node and ensures that containers in a pod are running. Now that we understand the basic structure, let's look at some key Kubernetes objects that you'll interact with to manage your applications. First up, deployments. These provide a declarative way to manage applications. You define the desired state, like how many replicas of your application should be running, and the deployment controller works to maintain that state. This makes updates and rollbacks incredibly easy and safe. Under the hood, deployments often use replica sets. A replica set's purpose is simple: to maintain a stable set of replica pods running at any given time. If a pod dies, the replica set notices and creates a new one to bring the number back up to the desired count. This ensures the high availability of your application. So, your pods are running, but how do you actually access your application? That's where services come in. A service provides a stable IP address and DNS name for a set of pods, acting as a load balancer and single entry point. This decouples clients from the individual, potentially ephemeral pods. A service is like the customer service number for a company. You call one number and you get connected to an available representative. Now, finally, we have namespaces. These allow you to logically partition your Kubernetes cluster, providing a scope for names. You can use namespaces to organize your projects, teams, or environments within the same underlying cluster. This helps with resource management and organization. Namespaces are like different departments within a company. They have their own resources and responsibilities, even though they're part of the same organization. So, why all the hype around Kubernetes? Let's take a look at some of the key benefits it offers. Scalability. Kubernetes makes it easy to scale your applications up or down based on demand. You can automatically increase the number of pods when traffic spikes and decrease them during quieter periods, optimizing resource utilization and ensuring your application can handle any load. High availability. With features like replica sets and health checks, Kubernetes ensures that your applications remain highly available. If a pod or even a node fails, Kubernetes can automatically reschedule and replace the affected components, minimizing downtime. Automation. Kubernetes automates many of the manual tasks associated with deploying and managing containerized applications, freeing up your team to focus on building features rather than operations. This includes tasks like deployment, scaling, healing, and rolling updates. Portability. Kubernetes is an open source platform that can run on a wide range of infrastructure, including public clouds, private clouds, and even on-premise. This gives you the flexibility to choose the best environment for your needs and avoid vendor lock-in. Excited to start your Kubernetes journey? Here are a few ways you can get your hands dirty. Learn the basics, continue watching videos like this one, and explore the official Kubernetes documentation. Local development. Tools like Minikube and Kind allow you to run a lightweight Kubernetes cluster on your local machine for development and testing. Manage Kubernetes. Cloud providers like AWS, EKS, Azure, AKS, and GCP, GKE, offer managed Kubernetes services that simplify cluster setup and management. Start small. Begin by containerizing a simple application and deploying it to your Kubernetes environment. That wraps up our introduction to Kubernetes. I hope this has given you a solid understanding of what it is and why it's so important. If you found this video helpful, please give it a thumbs up, subscribe to the channel for more awesome tech content, and let me know in the comments below what Kubernetes topics you'd like me to cover in future videos. Thanks for watching, and I'll see you in the next one.